question 4 on exercise 15.5. Okay, let tan inverse x over 3 and g of x be equal to tan inverse 3 over x where x is bigger than 0. Show that f dash x is the same thing as minus g dash x. So what we're going to start off is with f of x equals tan inverse x over 3. Now I'm going to put x over 3 in a box. Now what we're going to remember is the generic equation, which is that tan inverse x over a always ends up to be a over a plus x squared. Now what we have learned off by heart is that a always equals 1. Whatever is in this box, so we're just replacing a as 1 right away, and whatever is in this box is counted in the x position. So what's in the box is x over 3. And what we also remember is we got to differentiate whatever is in the box at the end. So to do the first derivative, which is f dash x, all that we got to do is we're going to put 1 divided by 1 plus bracket x over 3. Now that is a squared, by the way, but a squared is 1 squared, which is 1. X over 3 squared, and then we're going to have the derivative of x over 3, and to differentiate a third x is just the number that comes in front of it, which is a third. So we're going to have a third here, and then what we're going to have is we're going to have 1 divided by 1 plus x squared over 9. Get a common denominator. We're going to make that a 9 and that a 9, and then we have the 1/3 here, and finally what we're going to get is we're going to have 1 over 9 plus x squared divided by 9 to the power of a third. Now when we have a number divided by a fraction, what we do is we bring the fraction up to the top and turn it upside down. So we're going to do the exact same thing with what's in this blue box here. We're going to bring it to the top, and it's going to turn into 9 over 9 plus x squared. The 9 and that will turn into 3. So our answer will be 3 over 9 plus x squared. Okay, so that is f of x done. Now we're going to move on to g of x. So we have the answer for f of x, or f dash x. Okay, so f dash x was 3 over 9 plus x squared. Now g of x is tan inverse 3 over x. Now we have here is quite the interesting one. So like last time, a equals 1, and what's in the box is going to be 3 over x. So what we're going to get is g dash x is equal to a, which is 1, over a squared, which is 1 squared, over the box squared. And then we're going to have g of x, or sorry, differentiate what's in the box. So the d dx of 3 over x, which is basically 3 over x is 3x to the minus 1. So d dx of 3x to the minus 1. The minus goes to the front, and what we're going to get is minus 3 x to the minus 2. And what we know about x to minus 2 is it's 1 over x squared, which would bring that down to the bottom. Now that we're at this stage, what we're going to get is g dash x ends up to be 1 over 1 plus 9 over x squared. We're going to make an x squared here, divided by x squared, given the same denominator, to play with minus 3 over x squared. Now the two of these here, they have the same denominator, so we might as well join them up and give them the same denominator, which would be all over x squared. Bring this fraction to the top, turn it upside down, so we're going to get 1 multiplied by x squared plus 9, all by minus 3 over x squared. So what happens is the x squareds cancel, and our answer for g dash x is going to be minus 3 over 9 plus x squared. Now, we've just after proven that f of x is minus g of x, because minus g of x means multiply by minus 1, which is going to be 3 over 9 plus x squared. So we're just after proving that they're both the same. Now that that's done, what we got to remember is, what does the first derivative actually mean? The first derivative represents the slope of the graph. F dash x represents the slope of the graph. It's the slope of f of x. Okay, so it's the slope of f of x. Now, the trick is here, x squared is always positive. The top number is always positive and the bottom number is always positive. The slope of f of x therefore is always positive. And always positive means it's always going diagonal right up. The slope of g of x, however, is a negative number divided by a positive number, which means it's always negative. And always negative means it goes diagonal right down. So let's have a look at our two graphs. These two have the same direction of slope, has to be wrong. These two as well have the same direction of slope, has to be wrong. Well, this one here is always going downwards, which means it's always negative. This is the g of x function. This one is always going upwards. It's the f of x function. So the answer to this one is graph A. Okay. Now, this one here. The functions f and g are defined in the domain minus 1 to 0 as follows. F of x being tan inverse minus x over x plus 1. G of x being tan inverse x plus 1 all over x. Show that f of x is minus 1 divided by 2x squared plus 2x plus 1. Well, we'll just start off with that, and we'll say that f of x equals, what's it going to be, tan inverse minus x over x plus 1. Okay, so that is what tan inverse is. Now, what we're going to start off with is the usual generic formula. Tan inverse x over a equals a over a squared plus x squared. We always know for our differentiation a equals 1, so that might as well be a number 1, that's a 1, and that's a 1. Now, replace what's in the box with what is in here, and then differentiate what's in the box. So, what we're going to get for f dash x is going to be 1 divided by 1 plus what's in the box squared. Well, what's in the box squared is square minus x, and you get x squared. Square x plus 1, and you're going to get x plus 1 squared. So that's the box squared, so to speak. Okay. Now, what else wants me to do is to differentiate what's in the box. So I have to differentiate minus x into x plus 1. Now, this is a question to itself. It's a quotient drill question where u equals minus x, du dx therefore equals minus 1, phi equals x plus 1, therefore dv dx equals 1. So we have a bit of a side question going on here. So we're going to have is 1 divided by 1 plus x squared. This is all going to be divided by x squared plus 2x plus 1. That's that part squared out. Now I'm looking at the number 1. I need the same denominator, so I'm going to change this number 1 into the denominator here, x squared plus 2x plus 1 divided by x squared plus 2x plus 1. You can see that that's still the number 1. And now they have the same denominator. Now on this side here, I'm going to do the quotient rule for this part. Okay, so we'll just put the bracket in here, and let's see what happens. So we're going to do phi times du dx, which is going to be x plus 1 times minus 1, minus u times dv dx, which is minus x times 1, all over phi squared, which is x plus 1 squared. So now what we're going to have here is we're going to add the two of these together, and we're going to have 1 divided by 2x squared, which is this one plus this one, plus 2x plus 1. Okay, and that's going to be all over x squared plus 2x plus 1. It's basically the number 1 divided by a fraction. When you have 1 divided by a fraction, you move the fraction to the top and turn it upside down. So that is exactly what I'm going to do right now. So I'm going to drag this part here to the top, this one here underneath. I can get rid of that number 1 because number 1 doesn't mean anything. So this part underneath, and in effect I have turned it upside down. Okay, so that's that part there. Now we're going to work on this part to the side, and what we're going to get is this is going to be minus x minus 1, and then that's going to be plus x. The x's cancel, and I'm going to get minus 1 all over. This here is going to be x squared plus 2x plus 1. You can see the two of them cancel, and we can find out that our first derivative is this here. Okay, so that's what f dash x is. We'll just have to show that it is that. Now that I've done that, what I've showed you this is that it can be shown that f dash x equals g dash x, so both of them are the same. One of the three diagrams, A, B or C, represents parts of the graph f and g based only on derivatives. State which diagram is the correct one, and also state why each of the other two diagrams is incorrect. Well, the first thing I'm going to tell you about f of x is that if I was to change it to this on the bottom, x squared plus 2x plus 1. See what I did? I separated out the x squareds, and see this part here? That's a perfect square, so the first derivative basically equals this here. Now, this first derivative, it represents an equation of the slope of the graph. This equation is always negative. This means that the function f of x and g of x are always going diagonal right down, because the bottom number has to be positive and the top number is negative. It means a negative slope. So the two of these have a negative slope, and the two of these have a negative slope. However, this one here has a positive slope. So I'm going to rule out diagram C on the basis of it having a positive slope. Now, the next thing I'm going to look at here is if both functions are identical, it means that they're going to have identical slopes all the way through. Now you can see that these two here mirror each other exactly, but in this one here we can see that this one, f of x, is going more downwards. It's facing the wrong way. While it's going downwards, it's arcing like this, while g of x is arcing like this. So basically they're facing different directions, okay? So you can see that in diagram B that f of x and g of x's slopes do not mirror each other exactly. Do not mirror each other exactly, aren't exactly the same. Okay? It's like they're on separate points of a point of inflection, so it's like this. They're like on different sides of the point of inflection, so that's basically why I'm disagreeing with diagram B, and my answer is going to be diagram A.